In this video, we would like to answer the question, what can go wrong in hypothesis testing? That leads us to types of statistical errors. In particular, we identify two types, type 1 and type 2 errors, whenever we conduct hypothesis testing. So let's get down to what does type 1 error mean? What does type 2 error mean? Maybe before we do, we probably should identify what would be correct decisions in the context of hypothesis testing. You see, when the null hypothesis is actually true, well, if it is true, do we want to reject it or not reject it? I would argue that I would like that if the null hypothesis is true, we should not reject it. This is a correct decision. And in a similar vein, if the null hypothesis is actually false, well, I don't want to embrace that. So I would like to what? Reject it. So if it is false, I would like to reject the null hypothesis when it is false. These are both correct decisions, which leaves us with two remaining cells here that are unfilled. So we're going to fill them with either type 1 or type 2 error. So type 1 error arises when the null hypothesis is true and we end up rejecting it based on some error we committed while performing the statistical hypothesis test. Whereas type 2 error arises when the null hypothesis is actually false and we fail to reject it. That is an erroneous decision. So these are two events that can occur. These are two errors that can occur. How likely is it are they going to occur? Alpha that we've been using, this has been called the level of significance of the test in earlier videos you have watched while carrying on hypothesis testing. This is always the probability of type 1 error. And just as you can have the probability of type 1 error, we can also have the probability of committing type 2 error. The relationship between both of them is that none of them can be eliminated entirely. One, they are rarely zeros. You only have to, it's always a trade-off. You have to examine if the consequences of performing a type 1 error or carrying out a type 1 error is extremely large, you might try to minimize it. And that would mean that you are increasing that of type 2 error, which is represented by beta. So the only two hypothesis testing decisions are usually rejecting and not rejecting. So we take the first example here. If the consequences of making type 1 error are very severe, would you choose the level of significance alpha to be 0.01, 0.05, or 0.10? 1%, 5%, or 10%? Well, if the consequences are very severe, I will try to minimize it if I cannot eliminate it. So I will choose alpha to be 0.01. That is the most minimum value possible. Okay, then we proceed to the next example, talking about types of errors. According to a food website, the mean consumption of popcorn annually by Americans is 59 quarts. The marketing division of the food website unleashes an aggressive campaign designed to get Americans to consume even more popcorn. Complete parts A through C below. Question A, determine the null and alternative hypothesis that would be used to test the effectiveness of the marketing campaign. If this is a marketing campaign and we want to test the effectiveness, that test hypothesis should always go to the alternative hypothesis, and that will be consistent with what we have done so far. Currently, this is what the food website is saying that they're consuming, 59. If it is going to be effective, then the mean consumption must be raised beyond 59 quarts. So that is what will be what we want to test versus the null hypothesis that it is still at 59 courts. Then question B. A sample of 805 Americans provides enough evidence to conclude that marketing campaign was effective. Provide a statement that should be put out by the marketing department. Based on the descriptives of this question, if what the sample data provided by 805 Americans says that the marketing campaign was effective, an appropriate statement would be to say that there is sufficient evidence, that is, that would be the kind of conclusion, there is sufficient evidence to conclude that the mean consumption of proportion has risen above 59 quarts. This can be written as follows. There is sufficient evidence to conclude that the mean consumption of popcorn has risen above 59 quarts. Question C. Suppose in fact that the mean, take note, keyword, in fact, in actual reality, that the mean annual consumption of popcorn after the marketing campaign is actually still 59 quarts. Do you think, or has a type 1 or type 2 error been made by the marketing department? If we tested this hypothesis at the alpha equals 0.1 level of significance, what is the probability of committing this error? Something to immediately notice before answering this question is that earlier we had said that we concluded that the marketing campaign was effective. If we said it was effective, it means that we had enough evidence for the alternative hypothesis, and that means we must have rejected the null hypothesis. So that is the argument developed here, that since we concluded that the marketing campaign was effective, this means we must have rejected the null hypothesis. Anytime we reject the null hypothesis, let's go back memory lane. The only time when we reject null hypothesis, the only type of error we can commit in association with that kind of decision is the type 1 error. So that is what we have here. The only type of error that could have been committed in association with this type of decision is type 1 error. So that answers this part of the question. If we tested this hypothesis at alpha equals 0.1 level of significance, what is the probability of committing this error? That is, what is the probability of committing type 1 error? By definition, that is equal to alpha. And by definition, I mean earlier we discussed that the probability of type 1 error is alpha. And if that is the case, so what is the value of alpha? Alpha is equal to 0.1 according to the question. So the probability of committing this type 1 error is 0.1. So with that question also completed, we are now ready to move on to another example. A can of soda is labeled as containing 15 fluid ounces. The quality control manager wants to verify that the filling machine is neither overfilling or underfilling the cans. Complete parts A through D below. A. Determine the null and alternative hypotheses that will be used to determine if the filling machine is calibrated correctly. Well, if the can of soda is labeled as containing 15 fluid ounces, that means, as far as the null hypothesis or the status quo is concerned, we want to make sure that that mean is actually what we advertised is what it actually is. Then, the job of the quality control manager will be to check that it is not over, that is greater than 15, or under, lesser than 15. So that means we want to test at all points that it is not equal to 15. This is what we want to constantly test for. Once there is evidence to suggest that it is not equal to 15, we might need to recalibrate the machine. So that would be the setup of the null and alternative hypothesis. Question B. The quality control manager obtains a sample of 81 cans. So N equals 81. and measures the contents. The sample evidence leads the manager to reject the null hypothesis. Well, if we are rejecting the null hypothesis, that means we have sufficient evidence for the hypothesis we want to test. So we are ready to write a conclusion for this hypothesis test as follows. Since the manager rejected the null hypothesis, we can conclude that there is sufficient evidence in favor of the alternative hypothesis. That is to indicate that the filling machine is over or under filling the cans at this point in time. Question C. Suppose, in fact, the machine is not out of calibration. Has a type 1 or type 2 error been made? What kind of decision did we make in order to answer this question? Usually, what I do is I ask myself, what was the decision I took? I rejected the null hypothesis. Anytime I reject the null hypothesis, there is a potential that I might be committing type 1 error, because rejecting the null hypothesis sometimes may lead to a type 1 error. So to answer that question, going back to that table, in this case, the first part of this answer would be type 1 error has been made in this case. Then we read further. A type 1 error has been made since the sample evidence led the quality control manager to reject the null hypothesis when the null hypothesis is actually true. So this provides the answer to that question. Then, question D. Management has informed the quality control department that it does not want to shut down the filling machine unless the evidence is overwhelming that the machine is actually out of calibration. What level of significance would you recommend the quality control manager to use? Explain. The level of significance should be set as low as possible. So I would recommend 0.01 or 1%, because this will make the probability of type 1 error very, very small. We now progress to another example on type 1 and type 2 errors. So you have, for students who enrolled in 2-year public institutions in a recent semester, the proportion who earned a bachelor's degree within 6 years was 0.389. The president of a certain college believes that that proportion of students who enroll in an institution have a higher completion rate. So there's somebody making a claim there that the proportion is higher than 0.38. So we have to determine the null and alternative hypothesis. Null, alternative. So if we're talking about proportion, PP, higher than what? Higher than 0.389. And so this would be the null hypothesis. And question B, explain what it would mean to commit a type 1 error. Recall, this means rejecting the null hypothesis when in reality, this guy, the null hypothesis, is true. So to explain this in the context of this problem, it will be stated as follows. The president rejects the null hypothesis that the proportion of students who earn a bachelor's degree is 0.389, when in real fact, the proportion is 0.389. Then, part C, we are to explain what it would mean to make a type 2 error. This would mean to not reject the null hypothesis when in fact the null hypothesis is false. This is also an erroneous step, and in the context of this problem, this is what it means. This would mean, that is, type 2 error would mean in this context that the president fails to reject the null hypothesis. And what does the null hypothesis say? that the proportion of students who earn a bachelor's degree within 6 years is 0.39, when in fact, the proportion is actually greater than 0.389. So with that said, we have that question completed.